Hi, this is just a quick little impromptu video. So I'm working on a customer's 2071 stereo music intercom receiver. See, like this. And I've done the normal sort of rebuild part of it so far. It came in and the general description of it was it had very poor performance, it had very poor reception, it's just basically old and tired. And if you look right here, I think you can see it was made in 1966. So it's pretty old. Someone has been in here before and has worked on this before, because one of the things I found was this. And this is somebody's idea of a replacement 2-section CAN capacitor, which is pretty dodgy. And these are, there's no actual date code on these capacitors. Well, it could be 97 or 91 maybe. I don't know if the numbers stamped on the aluminum ends are valid or not. But anyway, so this proves someone's been in here before and has worked on this. And it was in pretty bad shape because these are two epoxy capacitors. I think you can see those. And if I turn them around the right way, you can see that they have failed and the outer covering has blown off of them and they're probably dead short. You don't even bother testing something like this because really what's the point? Once I got the normal rebuild done, which at this moment consists of, put these in here, this sack of parts so far, fired it all up, and while the FM works surprisingly well, because usually on early stuff like this, if you're going to have any kind of tuning issues, it always seems like it's the FM. That's just inherently the way it is. But I had no AM, and it was very odd because usually by default AM is great. AM is very simple. You have to start looking for what the source of the problem may be. What I found was interesting, so I thought I would kind of walk you through the steps it takes to do something like this. So where do you start when you're looking for a problem like I have no AM? First thing you do is you get out your trusty handy dandy NuTone service manual. And if you happen to have an original printed one, that's really the best way to go. You can get them in a PDF format on the computer, but reading them on the screen is never as good. And having a printed manual is really the way to go. Now you have to be careful because there are two versions of 2071s. There's the early ones and the late ones, surprisingly enough. And you have to have the right service manual because yes, there is an original service manual, that's this one, and then there is the addended or updated service manual for the revised later version. And so you have to make sure you have the right manual, otherwise you're going to spin your wheels. And service manuals are really great, gives you checkout procedure, master station, descriptions, connections, all that kind of goodies. And then if you flip through here, you have troubleshooting chart right here. And what you have to realize is, and this is the entire troubleshooting section, it's one page or half of one page, not a lot going on here, so it's very limited. And what you have to take into account is what it explains here and the trouble and suggested checkpoints here. You have to realize this was written for a guy like me when these sets were relatively new. If this was installed brand new and it had a problem, or if it was 3 or 4 or 5 years old, what they suggest here is more appropriate for a fairly new model than one that was made in 1966 and we're repairing it in 2020. So you have to take this with a grain of salt. How many times have I actually found clues or helpful information in NuTone troubleshooting section of a service manual? Not that many times. However, it's a good place to start because it sort of gets you into the mindset of looking at different sections of this model because those things are valid. So here's our problem. This is the second one. No AM radio, other operationals normal. And the suggested checkpoints are: check voltage readings on transistors number 4, 5, and 6. Check L5, L6, T5, T6. Those are coils and transformers, audio transformers, T7 and associated circuitry, check switch M2. That's a good easy place to start. And of course, first step in almost all troubleshooting is you measure voltages, because if you've got a dead transistor, checking a bunch of other passive components isn't going to yield any good results because you got a dead transistor. So then you flip ahead and you find the page that points out where the transistors are. That's in this photograph, and that's one of the nice things about these early manuals, where you actually have a photograph of the board. If it was color it would be better, but it's not, and it points out where the components are, because this is chock-a-block full of stuff here and it can get kind of confusing. And then if you go a little further, you can actually find the same board here, and it's the back side of the board, the foil side of the board, and it also shows where the different transistors are. We're interested in transistor number 4, 5, and 6, and it shows on in the photograph where they're located, which solder pads, and which pad is collector, emitter, or base of the transistor. So that makes that kind of easy. And then the other thing that's nice about this is, because this is a printed manual, you have this really nice 4-page fold-out schematic. And you can look at this on a PDF, but if it's divided up into 4 or 5 pages and you have to scroll back and forth, it's a pain in the neck. There's nothing better than having an actual printed manual, because it's clear, easy to read, and you see all the connections, and it just makes life really easy. So that's where we started. Since we're measuring, checking voltages on transistors, you have to look on the schematic, because on the schematics here, for instance, here's transistor number 5, and it shows what the voltage measurements should be on the collector, base, and emitter, and you measure it, it's DC voltage, and you're measuring it in reference to the ground, the chassis ground of the unit. So that gives you a good starting point. So the next step was this. You're looking at the back side of the 2071. You're looking at the foil side of that circuit board in the service manual, and you'll see here is transistor 4, and here is transistor 5, and here is 4, 5, and 6. And you'll notice that I put little red felt marker on the pads that are associated with those transistors, because that just makes my life a little bit easier. It's that way you don't have to hunt around for them every time you have to go back and check something on them. They're easy to identify. Now, one of the things that you have to know on this model is transistors typically have 3 leads. They have a collector, an emitter, and a base. But you'll notice here we have 4 leads on each transistor, because one of the leads goes to the outer case, and that's the way a lot of early transistors were made. You have to be careful that that doesn't trip you up, because there are transistors that actually do have 4 leads. They are usually FETs and not standard small signal transistors, but that's not what's being used in this case. It's just the way transistors were made back in the mid-60s. So I set up my meter and powered up the 2071, and I went through and I measured voltages and compared them to the schematics, and they were within 10% plus or minus of what the schematic shows, and that's usually typically fine. The measurements, the voltage measurements in the schematics, are the ideal measurements that an engineer would have calculated when he designed the circuit, and what you get in real life is oftentimes very slightly different, and you can't get hung up on those small details. You know, if it says you're supposed to get 9.6 volts DC and you're getting 9.4 volts DC, you're fine. It's within tolerance. It depends on the actual voltage powering the set and other things that can affect what the actual measurement is, and the ideal in a calculation doesn't normally match what you get in real life. Since our voltage measurements on our transistors were pretty much okay, then we have to go on to look for where the next problem could be. Now, one of the things I noticed was when I tried to operate or play an AM signal, there was no sound. It wasn't tuning in, but there was sort of a odd type of, it wasn't really a received signal, but you could tell that it seemed like it wanted to work, which sometimes that can be, it's hard to describe that exactly. You sort of get a sense for it when you fix things all the time. A circuit that seems like it wants to work, but it's not really working, and sometimes those kind of problems can be caused by bad solder joints or loose connections or things like that. And that was sort of the impression that I was getting. So with that in mind, I started looking at the schematic here, and in the troubleshooting guide, after the transistors, it said to check the coils, which are L5 and L6. So L5 is here and L6 is here. While I was thinking about L5 and L6, one of the other things that you have to take into consideration, see, a lot of this you think about when you're doing it, you sort of think about all of this automatically as all the pieces hopefully start to come together. And we'll go back to TR4 for a second. So TR4 is the first FM intermediate frequency amp and AM converter transistor. Now our situation was that the FM worked well and we had no AM. So if this transistor was bad, chances are we'd have no AM or no FM, because this transistor works in both the AM and FM circuits. There are transistors that are before this, they're that way in the schematic, which are TR1, 2, and 3, and those are strictly FM transistors. They're the FM RF amp and the FM mixer and the FM oscillator. So if one of those three were bad, you might not have any FM, but your AM would work fine because it's before the AM. So this is like your first AM transistor. So if the FM works fine, the odds are these other three transistors are probably fine also, but you still have to measure voltages to make sure. Now, so the other thing in looking at L5 and L6, the first thing I had to do is I went back to the pages with the photographs to figure out which ones L5 and L6 are, and it shows it in the photograph. Then you reference it to the back of the board, and that way you can find it in the set for real. When I was doing that, when I was finding them in the set, one of the things that I noticed was part of that circuit, part of the circuit of L5 and L6 is the variable tuning condenser, which I'll show you in a minute, for the AM tuner. And that's the part with the fins, and like I said, I'll show you that. So here, this is L5, and the tuning condenser is C25, which is this little thing right here. And the other part of the tuning condenser, C25, is here and is connected to L6. Now, one of the things that I did when I was replacing the sack full of components yesterday, to be able to open the set up to get to the inside of it more easily, and this kind of set is a pain in the neck because nothing is plugged in. Everything is point-to-point soldering. So there's some wires that are incredibly short that you have to desolder from the board, and that helps you fold the set open so you can get your big giant hands in there and work on it. One of the things I noticed when I was looking for L5 and L6 was that next to L5 and L6 are the wires that come from the tuning condenser, which is a mechanical part on the front of the set, and I unsoldered those and labeled them so I know when they would go back in. I did that so I could open the set back up. L5 and L6 receive the signal directly from the tuning condenser, making L5 and L6 very important part. So this is the AM tuning condenser. You have these series of fins, and when you turn the knob, they rotate, they fold in and out of themselves between the fixed ones, which are down in the bottom down here, and that's how you tune your AM station. There's a yellow wire here and a white wire here. The yellow wire goes to L5 and the white wire feeds into L6. So the signal through the tuning condenser feeds directly into L5 and L6, and that's what makes L5 and L6 really important. Once I figured that out, I started looking actually at L6 first, because L5 is hidden down underneath this metal plate, and being lazy or whatever, I didn't feel like taking that off again right at the moment. So I figured I'd start with L6, and then if that didn't give me any kind of good results, I would move on to L5 and have to take the plate off. So this section of the board right here, where we have these 5 holes, this is where L5 is installed on the other side of the board. This one portion of this pad right here, where the wire is still soldered on, that's the white wire that comes from the AM tuning condenser, and then you've got 4 connections or 5 connections around here. and all of these, this one, and this one, like most coils have 4 connections and then sometimes one that feeds in. So this is the one that feeds the signal in, and then this is one adjustment and this is another adjustment. And so I did a quick sort of continuity check to see if I had continuity between all of the primary pads, which are these 4, to the next pads on the board. Those all seemed okay. And then I did one, of course, between the white wire here and this one, and that was okay, and the white wire off the tuning conduction to here, and that was okay. And then I started looking at the coil more carefully, and I found something really interesting. And here we have little L6, and it's a pretty standard tuning coil. And you'll notice right here I marked this leg with red just to help me index it. It really only fits into the board in one way, but it helps orient it when I take it out so I know what I'm looking at. It's just the way I do things. And what I noticed, and I noticed it before I even took it out of the set, is that so you've got the lead or the terminal here. This is the end that goes through the board where it's soldered. And then there's a little fine wire that comes off of it, and it goes up here, and then it just ends. It's broken off. And if you look on the cardboard tube, you can actually see, because when this was made, the wires are all wound probably by some machine, I'm sure, and then it's got sort of a coating, maybe some kind of lacquer coating or something, and that sort of seals it all together so the wires aren't loose. And you could actually see in the lacquer where the wire used to be sealed in onto the tube with the lacquer, but right now it's just flopping around like this. So we have a broken connection. So I did a quick continuity check between the little tiny bare end of this wire and the white wire on the tuning conduction, and there's a connection there, but obviously it's broken off here in the coil. So I took the coil out, and then I looked at it very closely under magnification to see if I could figure out where the wire had originally came out of this bundle that's wrapped right here on the coil. And as I looked really carefully, I found over here, and this has already been pulled up, this is the other end of it, and you could tell that because this wire, this is a very fine stranded wire, and it has sort of a woven or cloth cover over it, and you could see the frayed end of the cloth right there where it was broken off. So someone at some time, because this didn't happen on its own, wires don't mysteriously break, and also, you know, if you think about it, it's nearly like a 3/4 inch piece of wire is missing out of here for some reason. So someone did this sometime in the past. I'm guessing when those clunky capacitors were put in and somebody was kind of ham-handed with the whole thing, and somehow the coil wire got broken. This was a good find, and it was probably a lucky find to some degree, or it was, I don't know if lucky is the right word, because you have to sort of use all of your experience in trying to sort out what the problem could be. And since it was an unusual problem, then you have to look for unusual things. So what am I going to do with them? You can't simply replace the coil. You'll never find a brand new one like this, because parts like this most commonly aren't made anymore. They're not used in new products anymore. There's other ways to achieve its same function, and anything that you found that could possibly work would be so incredibly small, and trying to mount it in the set would be so incredibly difficult that it just isn't worth the effort. While I do have a couple spare 2071s at the shop, I'm not really that big on robbing parts out of them if I can come up with another way to solve the problem. So what I'm going to do is I'm going to take a little piece of wire like this, and this is about the same size as the wire that's in the coil. It might be little bit heavier, but it's very small. I forget what gauge it is. I think it's like 48 gauge. It's little tiny thin wire. And I'm going to splice it on to the bare end right here and solder it, and then I'm going to run it down to the terminal down here and solder it on. And it's not going to make a change in how the coil works, because it's really like the lead-in wire from the terminal here into where it's wound into a coil. So it's not going to make any difference in how the coil works, and then we'll sort of put some adhesive over it to glue it down in place so it's sturdy, and we'll put it back in, and if we get a little bit lucky, we'll be able to hear AM. I just thought I would show this because this is not the most common type of problem you run across, but it is the kind of problem that you run across, and it can be tricky to figure out, and you have to use all of your senses and your experience and think about what's going on and sort of work through the problem to see if you can find a solution. If it works at the end, you'll get to see the 2071 play. If it doesn't work at the end, then there'll be another part where I look for more problems. Okay, I'm back. So here's our repaired L6, and you can see the little yellow wire I added on, and it's soldered onto the terminal down here that goes through the board, and it wraps around the coil, and then it's soldered onto the broken end down here where you can't really see it. And right now it's still kind of loose because I'm not going to seal it up with anything or seal it on there until I know that it works, because I might have to take it apart again. So that was pretty easy, and as difficult as that seems, it actually wasn't that hard to do. So let's see if we did any good. If we did, we should get something. So I've got it all set up. It's powered up by an original transformer. I've got it hooked up to an AM/FM antenna. I've got it hooked up to a single pair of speakers, and if we turn it on, lights come on, and we have AM. And you can tell it's AM because if we change stations,
on track. Yeah, that's a great question. I think it does.
we need to turn the shop lights off. There we go.
Since between like what's happening in their process, maybe.
Hey, and use discount code KGO. As we begin the 4th week of May,
I didn't make this because I want...
And this guy Ryan Garcia. Now I want you to give me another chance. I have spent.
As whether that the number was an
Wow, a music station on AM? How weird is that? Go back up here.
Are realizing the power and benefits of good nutrition.
That's 810. 810 is our local Bay Area powerhouse station, 50,000 watts, KGO 810 in San Francisco. So, what started off to seem like it could possibly be one of those really long and drawn out, horrible, pound your head on the wall kinds of problems, actually went along pretty well. It didn't really take that long to figure it out because I tried to work through the problem methodically, a little bit of tips from the service manual, which I have to say is unusual. Usually they're not much help at all, and then pretty much start at one end and work through the circuit looking for a problem, and we found it, we fixed it, and we're good to go. And this is also something that you should keep in mind if you're working on a set or if someone else works on a set. Watch your hands. Don't break things. You're supposed to be making it better, not making it worse. I hope you found this interesting, and maybe for someone it'll be helpful. If it is, please give it a thumbs up on YouTube because that always helps. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications, and every time we post a new video, you'll get a notification, and you can watch it. That's all for today. See you on the next video.